king, everything that I say hot.
View disembodied content. Parental discretion is advised.
So I think I finally managed to get all the problems solved. So here we are. Welcome to the stream. Music seems to be running perfect. All right, let's go. Today I wanna go back in time to a time when I started programming. Back then I was doing a lot of visual stuff, like creating fancy image editors or something, like scripts that edit images. So that was a lot of fun for me. And today I want to go back, now that I finished my my degree. So I want to see what I can do. And the thing is, so let's first get to the desktop. Okay. I think I can get that a little bigger, move it a little bit further down. Okay, perfect. Now, I hope that you can see everything. Let me get the text size a little bit bigger, even more. Okay, so what I'm using is P5.js. I've never actually used it. I have done a lot of processing, which is a Java-based thing that's very similar. But basically, it gives us some way to code and get a visual output, and brings all kinds of drawing functions with it. So, in order to save sketches, you must be logged in. Is there a shortcut for actually displaying this thing? Yeah. I have to press this all the time. Auto refresh. Perfect. That's what I want. So now it's a little bit under the camera. So let me get that and make it a tiny little bit smaller. Okay. So the thing I want to do is basically, let me first check if the stream is up and running correctly. I had to open Edge because Chromium for some reason doesn't support live streaming for me. I'm not sure why. And well, somehow my YouTube app on my phone is broken, like suddenly. For some unknown reason. I have no idea why. I would love it to get back working. But oh well, what you gonna do? So the thing that was inspiring me to do this kind of live stream, I saw some guy. It was, what's his name, Randy something. He's been doing game programming for lots of years now, and he was doing something like procedurally generating the the ground for his game, and he was looking at a GL shader tutorial, but I couldn't find it. I couldn't actually find the page that he was looking at. And there was some kind of rainbow vortex thing that really was very cool looking that I wanted to recreate. So here we are. Let's do it. So first of all, we got a canvas that's 800 by 800 pixels, which is fine, I guess, but I want to get variables for this. Width is 800, and I'm writing JavaScript. I have not a lot of experience in JavaScript, but whatever, we're gonna go with it. So 800 by 800, let me get the width and the height, perfect. And it works, okay. So we have a function setup, which is called once. Once we start the thing, which just creates this canvas here, and we have a function draw, which is called every frame, which basically redraws the background every time. So now let's draw the background, and for a quick test, let's draw a line from 1010 to 2020. That should give us a small little line. Yes, it does. All right. So that's a good start, I guess. Okay, but not actually. So what we want to do, how do I visualize this? Basically, we want to get a swirl just like the Edge logo. Let me get to the real good software like Paint. And can I get a big stroke size? So I want a spiral, and I want it to be colorful. Like really rainbowy, like red, and then inside of it orange and stuff. The way we're gonna get that is, like, that's a really shitty image, don't get me wrong. The way we're gonna do that is we need to somehow calculate a spiral first, and then we can go ahead and map these things to different values. Or maybe let's first of all start with a full transition of all colors, of all hues around the thing. So first of all, I need to find out how to, is there a P5JS reference? Yes, there is. So I want to get started with color, and I want it to be HSB. That would make it, oh, okay, so we can do color of HSLA, which means hue something, lightness alpha, or HSL, perfect, HSL, that's even better. Hue, saturation, lightness, of course, sorry. And okay, I want to go ahead and draw some points. Can we get a pixels array? That would be perfect. Shape vertex, and I want to do every pixel by itself. So data something events, no, image, create image, get pixels, blah 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 blah. Okay, maybe I don't want to get an image. So let's start first with the let's say naive approach of just drawing a point. Point does get parameters. We can say stroke weight 1. Okay. Can we get stroke? Can we get the reference for stroke, please? Stroke. And we can just, can we put in HSL something? Yes, we can. Okay. So let's go ahead. And first of all, let's draw a point for a spiral. Oh, no. That was wrong. We go through each pixel. We calculate the angle of it relative to the midpoint. and then we assign it a color. Okay, great. How are we gonna do this? So for int I, no, we don't do ints here. Let I is 0, I less than width, and I first of all want to get j, because we want to loop through every line first, so it just makes sense. J less than height. Is there y? Oh, I'm touching the wrong key. Kirill King, hello from Turkey. Wow. Hello. What's up? How are you doing? So j++. Let's do that again. Let I 0, I less than width. Why am I don't know. Plus. And I would love it to edit my code for me. Okay, so now we are looping through every pixel, every frame. Okay, now we need to get the angle of the point. Let's look up how we get the angle of line between 2 points. And the A10 of something. Okay. Okay, apparently we need the A10-2 function. JS A10-2. I'm not even sure why 2. Math.A10-2. Okay. And I want to get this 1.1 to 0.2. We need the delta, and just plug that in there, and we get a radiance thing. Okay, so let delta x be I minus width divided by 2. Let delta y be j minus height divided by 2, or maybe what do we want? I guess there has to be some kind of thing. Well, we'll just try it out. Whatever. Do we actually need the angle? Yeah, we do. And that angle is math A10-2 of delta x and delta y. And then we draw first of all, let's set stroke weight to 1, and of course we want stroke weight, not stroke height. And let's get this going. Let the angle be blah 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 blah. Okay, so color, no, stroke off. No, we want single HSL. Why is it lagging so badly right now? Hello? Oh, we are... It's not happy. Oy. That's not good. Okay, let me look up how to do the image thing. Okay. Image. Image. Let image. No. We don't want to load image. We want to just get a pixel buffer. I just wanna get the individual pixels, load pixels. What do you do? P5.js load canvas pixels. Perfect. Swell width height. Okay, perfect. The rectangle image, whatever. So we want to stop this. Please don't auto refresh for now. Oh no. Oh no, it's still laggy. Don't set the stroke weight. Don't do this. Don't do this. Oh god, it's lagging so bad. Stop it. Stop. Okay. Reload. Yeah, now we're cooking. We're back. So, okay. So now that we're not refreshing, I can uncomment all this and go ahead and go on. So once we set up, we want to get 0 width height, and we want to save that into let img. Img is this, and then we want to get back to the reference and yeah, load pixels. Function setup, load pixels, then we do that stuff. So set will go ahead and zero img. What is it doing here? Change the color of any pixel or writes an image directly to the display window. Next environment specify the pixel to change and see the color value. Okay, so we have number object, pixel array, p5 color, p5 image object to copy. Perfect. Then we go ahead and put this back here. Set 0 img. Okay, and let pixels. I'm not sure if this even works, but I guess it should. And we do pixels is load pixels of img, or do I have to call that on the object? Set. Okay. Load pixels. No. Load pixels is called. Where does the pixels variable come from? Okay. Okay, so pixels is just some load pixels. Okay. So this is a static something array. Only changes made with set or direct manipulation of pixels will occur. Load pixels. So then we have update pixels, which should actually redraw this thing. Where is it? Update pixels. So it's the YouTube app is still not working somehow. Okay. But the stream is still up and running. Okay, perfect. That's nice. And here we go. Okay, update pixels. Updates the display window with the data in the pixels array using conjunction with load pixels, blah, 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 blah. Okay. Update pixels. All right. We don't need to set anything. We don't need to set this. We just do load pixels. You don't even need the image. Perfect. We don't need the pixels array. It's just all going by itself. So do I need to call load pixels every time? Load pixels for the display on the pixel array always be called before reading from or writing from. Okay, so I guess we need to load the pixels every time. Does anyone know? I guess not, since no one's watching. Okay, load pixels, update pixels. Good. Okay, here we go. Okay, pixels at. I need to look at the reference for the pixels array again because I think it's, yeah. I need to do this thing. Pixels RGBA. Okay, let's just copy this code from the thing here. I'm not sure why they are using the density thing. Because, okay, let's look at it. uint8 clamped array containing the values for all the pixels in the display window. These values are numbers array. The size including appropriate size of the display window times 4. Okay. What's the pixel density? Pixel density scaling for high pixel density displays. Set to match display density. Call pixel density 1 to turn this off. Okay, whatever. I don't think I should care about the pixel density, right? Because the index, why should this go into the index? So we're doing y times density plus j as width, y plus j. Why are we adding our x value? Oh, okay. Something density. Okay, so we actually do need this. Okay, I'm not sure why, but we're just gonna run with it. Okay, so here we can. We don't want to loop forever. No, we want to loop over. Okay, so these go in here. Nope, this goes there. This goes here. This needs to go one more. Okay, this also. Good. We need something different than I and J because we already used that. Dx. dy. No. First we do dy. Then we do dx. Dx. dy. Dy dx. Okay. The syntax highlighting is really weird in this editor. Okay, whatever. We're just gonna go ahead and why? No, I don't get this pixel density thing. The density should have nothing to do with how many pixels there are, right? This should still be a 100 by 100 array. So having a lower pixel density would mean we put more pixels in a higher pixel density, we put more than one pixel in an actual pixel. So we just create some kind of meshed color, which is not really that nice, but whatever. Okay. We will go with it. And okay, let me clean this up. We want to go ahead and call these we want to call this y, this is x, y, x, y, and all right. Now, basically, if we want to put this into this one, we want to multiply the height with the density. So where do we get the density? This was in here somewhere, I think. D is pixel density. So we set the pixel density here, we multiply it by the density, and then we get the actual x values and don't need this. Okay, so now we get too many parentheses here. Can we do can you format code? Tidy code. Perfect. Okay. So the index is gonna change. We don't need the d times y anymore. We basically just need 4 times y times width, right? No. So we go in steps of 4. We go ahead and say for every y we go one width, so y times width, which is correct, times density, which is also correct, and then we add the x, and that's it. and this also needs to be multiplied by 4. So we should get something correct, I hope. We're gonna see. So now we wanna set these to actual values, and we go ahead and let C equal color of HSL, and that's gonna take the angle. Oh, wait, let me look up the color function again. Color. There was something about HSL, right? HSB, which is just fine. But it always takes a value from 0 to whatever, 360, I guess? Or 255? I don't know. So we go ahead, HSL, we want just full saturation, full brightness. So how do we do template strings in JavaScript? Okay, let me real quick look at WhatsApp. I need to select a food for later. So what am I gonna eat? I'm gonna eat some salmon, teriyaki salmon. Sounds good. So now that I've got that out of the way, template strings in JavaScript. I think, yeah, those were the ones with the backticks and then a $sign. Okay, so backtick, just one please. HSL, we want dollar angle, and we want a 100% and a 100%, or let's go with 50% brightness for now. And the angle should be in radians, so we need to convert it to degrees. Or where is the HSL thing defined? Is there a reference thing? HSL? Nope. Let's go P5JS HSL. All right. Hue. Can you just not tell me what kind of range it accepts? HSL normalized hue. HSL values. Is there some standard? Hue 0 to 360. Okay, so we actually need to get pi into this. And JS pi. Math.pi, all right. Angle divided by something times pi, right? Get this real quick, okay. What's the conversion again? So in radians, we go from 0 to 2 pi. And we want to go from 0 to 360, so we divide by 2 pi and multiply by 360, which means we multiply by 180 and divide by pi. Okay, so angle times 180 divided by math.pi. And this should hopefully work, right? Nope. R is not defined, of course not. C, no, we need red of C. We need green of C. We need blue of C. And we need, can we just go alpha of C, I guess? Okay. And that looks promising. And it is really laggy, so why is that? Should we go with a smaller canvas for now? Can I stop it? Please? Please stop. I need you to stop right now. Okay. Let's go with 200 for now, since we are just proving the concept. So, okay, something is off on our angles, I think. I need to look into polar coordinates. Polar coordinates. So we got an angle and a point. We want the point to that angle. So we want actually we have the x, we have the y, and we want the angle here. How's this again? R times cosine y, so we need this. We need this angle. Why is there not such a good formula for this? Angle of line between 2 points. There should be. Or is there? Or is this thing off? Since this goes actually from... Oh. Oh, so I think I'm doing something wrong here with the pixel density, since we need this thing to be d times the thing, and reload, and this didn't change anything. Okay. We just had math A10, JS A10 2. Oh, so this, no, this gives us radians between negative pi and pi. Is that something we can work with? I don't think so. We need to add pi actually. Math.pi plus. Okay, so now we're getting something a little bit better. Which is okay. We're getting at least all the colors. But our angles are still not really on point. We only get eight distinct lines. So what is the problem? So the x and the y, we go from every point and get a vector to this. So the color thing is working. The color thing is working. Why are we not getting the correct indices? Y times width times d plus x. Can we just like go ahead and put in 255 for this? That does not change anything. That's too much. Okay, so why are we getting something different here? Can we like set the pixel density? Pixel density. Oh man. Nope. Does not change anything. But let's keep it linked. No, let's go ahead. Okay, so where's the problem? Where's the problem? Let's go ahead and go through everything again. Let's go ahead and how do I oh boy, where's the stream? Some technical difficulties. Okay, let's do some rubber duck debugging. We go through every y value and then through every x value, and we go for every y times the density. So if we have more pixels, we just go through it more times. Okay, now we add 1 to y, add 1 to x. Okay, then we get our angle, which is we can imagine it as an arrow from the midpoint, which is width divided by 2 and height divided by 2, to the, so we go from point to stem. Yeah. And then we go ahead and do the atan of that. Oh, am I mixing up the values? Yeah, we need to put in y first. Okay, so that would make a difference, I guess. Delta y and delta x. Okay, so this turns it by 90 degrees, which is fine, I guess. But not really important. Okay. So we get an angle. Then we go through every index. Every index is split into 4 sub-indices. That's why we do times 4. Then we go ahead and update the index plus 1, index plus 2, index plus 3. That's the color, and the color seems correct. So there has to be something wrong with the index, right? For every y, we go to full width. and full width times the density. And then we go the X, which already has the density built into it. So why are not working? Why is it not working? Why is it not working? Can we see out? No, it's not see out here. We need to console log the index. Does that work, or will it crash? Are we getting the index? Oh no. Hello? DevTools? Are you alive? Web developer, toggle tools. Look promising. Well, it's really laggy, so I probably shouldn't have done that. Oh well. No, I don't want to leave the page. No. Okay. So the console didn't log anything. Oh, yes it did. Yes it did. Yes it did. Oh god. What have I done? And that, folks, is why you don't program in JavaScript. Oh man, I just wanted to do something like real fast, real fun. Go ahead and do it, but this thing. It's not performing great. Let me tell you. Oh god, why is it? So, now tell me. You have all of this computing power. What's still running even? Why is it still running? Firefox very high. That's not good. Okay. Let me refresh this. No, don't refresh it. Can I clear the console? Trash it, please. Yes, thank you. So that should free up something. Okay. Console log. Bad idea. And so why is it working for some values? We start from 0. Let me first start again. We start from 0. We go to height times d. We start from 0, go to width times d. X minus d times width divided by 2. D times height divided by 2. Angle is pi plus thing. Okay. I don't really see the problem here. Okay. And the things it was giving out were pretty normal. Or is 16,000 something normal for 200 by 400? That should be 40,000, nothing more. Oh, so yeah, we do by 4. Okay. So let me look at this. So we should have 40,000 pixels, which means every pixel has 4. We should get 160,000 out of this, which is fine. So let me open a calculator. 4 times parentheses 200, which should be y times d times 200 for the width times d, which should be 1. Or like 100. Okay, let me start over. Okay, so 4 times parentheses 199, which would be the last iteration of this, times the width, which is 200. Let's keep the d at 1 for now, and y times plus 199, which is about that much. Which makes me wonder, why is it not working? Why is it not working? I'm definitely doing something wrong, like 100%, because I should be getting a lot more. 199. Like, this should really give me like 1600 and like 195,996 should be the oh yeah, right, because I was doing something wrong. That's the reason. Okay, so let's clear this. I have forgotten a 4 times parentheses 199 times 200 plus 199 for x, and close the parentheses, and we are done, and we get the actual value. So why is it not working? I'm sure it's some like very, very tiny mistake. But do I load up processing just for this? Do I do that? There's probably some mistake for some value. Probably some kind of rounding error. Some weird rounding error. Okay, you know what? Let's get processing. Processing Java. Let's go. Downloading it for Windows 64. Open it. Okay, that's gonna be real fast. Let's save it to programs. Oh, I actually have it. There should be nothing here already. Okay, let's copy that over. And that should be done. Hello? Can you please be alive? Oh, no. Oh, no. It's having a hard time because I'm also recording from that drive. Like, hello? Are you alive? What's taking it so long? This is not... The disk is not even working. Hello? What is this? Something's wrong. I can feel it. Please just copy it over. Come on. Come on. I might have to stop this. Stop. Maybe then you run fast. Well, apparently this really slowed it down. Okay, now we got this. We can start it. Yeah. Get started. Oh God. Preferences. Give me like font size 34. Like, can I get 28? Is that possible? Yeah, that's good. That's good. Okay. We need to get this to Java notation, integers, void setup, void draw. Then we need semicolons. I'm just gonna copy and paste. Oh, and then we need to think about how this thing should work. Yeah, maybe it didn't work because I didn't actually assign a variable to this. Whatever. Okay. Create canvas is not a thing. So now we don't need the P5 reference anymore. We can leave the page. I need the processing reference. Language reference. And I need the reference for first of all, where is A10? A10 2, we have that. And I need, what do I need? Create canvas. Canvas. Oh God. There's probably some kind of an example. Width and height. Size. We just need size. Perfect. So we have a okay, we don't need the density thing. We remove that, just flat out. Remove that, we don't need math, we just need A10-2. Let me look at the formula for this. A10-2, what does it return? Oh, where is it? Math. Trigonometry. Where did it go? Oh, where I was in examples. So I want trigonometry A10-2. It returns a value. Range from pi to negative pi, which is what JavaScript was giving me as well. So here we have a D left, and this thing needs to go from something. We have ints everywhere, so let's get this going. We need a float for the angle, int for the index, color. They really call it color. Let me get a keyword. So I think the implementation for the pixel thing is different in P5 and processing. So load pixels. There it is. load pixels, then we magically have a pixels array. Update pixels just is quite the same, and then the pixels array. Oh, it also has this pixel density thing, but I don't care, so we can just assign the color to the right thing. Okay, so we just do C, or we even inline this, so we just remove this and do color something something. And I think we can just do color mode, which I could have done before. Color mode HSB, hue, saturation, brightness, and then we look at color constructor, which just takes the whatever the values. Angle something something math pi, I think that's a constant here, and should take like 1.0 float maybe. And we don't need the backtick, we need these, we don't need this parenthesis. The size of the sketch. Oh, okay. 200, but I think we have a binding for height and width here, which was probably the case. Can I convert from double to float? So probably math.pi is a double, so we get a double out of it. Float, float, float. And we can do float. I think that's a function here. Java double to float. Okay, so we just cast to a float, whatever. And this is correct. I don't want to save it, I just want to run it. And that access array index out of bounds. Because we don't use the freaking for thing. So let's simplify this. We don't need any parentheses here. Perfect. Oh god, what's happening? I guess we're getting something different here. So probably we don't need the thing from 0 to 2 pi. We need it from 0 to 1, maybe? Color. Like this documentation, just like any documentation, is really lacking. Can I get YouTube? Let me restart my phone. Okay. Color mode is what I wanted to search for. So mode HSB max. Oh, so I can go from 360 to whatever. Okay. So we just do color mode HSB 360. How about that? Nope. Not yet. So I think this time the problem is in the drawing. So let me print the index for now. That should hopefully work in this thing. So we go from 0 to 40k. Can I make this bigger, maybe? Okay, that's a weird cursor for this. Okay, stop it, please. Please stop. And it's just so, oh god, those are too many values. Let me just print this. So we go from 0 to 360 all the time. It should be correct. So what's the problem? Are we doing some kind of int stuff? That shouldn't be happening. Can we take, let me take this color. Color C is this. Set C. And then we go C dot red. Is that a thing? C dot R. Red of C. That's a thing, okay. Rerun it. And we always get 0, so that's the problem. Color mode. Color 180, 50, 50. Do I need to convert it to an int? Does it take it then? Let me go ahead and do like 360, 100, 100, and put in 100 and 100 here. Yeah, we finally got it. It only took us 60 minutes to get something working. Yes, okay, so now let me turn this off. Okay. So now, I'm thinking, do we want to first spin the thing or do we want to get the spiral thing first? I think I want to do the spiral thing for this. I need the vectors, so let's get two things. So I think the thing we want is a p vector in this program. P vector midpoint. We only need to calculate that once. Midpoint is x of width divided by 2 and height divided by 2. So we don't need these deltas. These are gonna get different. So p vector current is a p vector. Of course, we need to equals p vector. This. And we need new, because it's still Java. New p vector of x and y. Then we do semicolon. It's never used. Okay. Yeah, sure. And we do a p vector difference is we go point to end, which means we go current minus midpoint, and we are in Java, so we don't have extension functions. Subtract midpoint. Let me look at p vector. And we have sub for subtract. Sub the midpoint, and we do difference dot y, difference dot x, and you should be happy now. So let's try it again. It's still working. Perfect. Great. So now we can do all other kinds of things. So we can do the length. So first of all, if we let's look at it. Let's look at the thing. We have this thing. We wanna, the further we go out, we wanna turn it to get a spiral. Okay. So what we want to do, we want the length of the vector to our, from the midpoint to our new point, and we want to add to our angle by that amount. So we want a float, a offset multiplier of 0.01 for now. Okay, now let's go and add to the angle. Okay, we can't do that. We want to clamp that thing later. So can we, is there like color clamping? Something? Clamp? Constrain. Constrain. Okay, but we want, I want just straight up modulus, so angle is that thing. Okay, do we have, I actually don't want CL map, I want clamp, but whatever. I want now to have, what did I want? Modulo, float modulo. How about negative values of modulus? It doesn't say anything about negative values, so let's just hope. Modulo 2 pi 2 times pi, and we need to put this into parentheses, and so we can now put parentheses for this one and go ahead and get the difference length. Oh, I think I need another function for that. Let me get the p vector page again. We want the distance, which is just dist. Let me get a real quick look at my phone because it wasn't working before. If it's working now. Okay, so difference distance. Right. Okay, no, that's not what I want. I want the length. The length. Magnitude. That sounds like the right thing. Okay. Mag. v.mag. Oh, so I need to multiply it by the offset multiplier. So how far plus thing variable offset mult. Okay, so now let's try it. Okay, so the thing with the clamping is not working, the rest is. So we just go ahead and add pi to it. Pi plus. How about that? Yes. So now we get a great spiraling effect. And if we select a higher offset multiplier, we should get a stronger what's it called? Stronger curve, whatever. So what if we go like extreme and get really curvy? So yeah, we get a curve. Okay, so but I think 0.015 should be good. Yeah, that's a good thing. Okay, now let's get the thing spinning. Let's get it to party. Okay, let's get to the concept of time. Float time. Start from 0. We have something called delta time, I think. Delta time. Yes. Processing 3.0. Delta time. Forum. I want the reference. Millis. Delta time. The forum. I'm pretty sure I didn't have to do it with that. Delta fix my solution to no delta time. Something variables. Okay, I think he's doing something really smart. He's doing fixed delta's time step. So it's running like same speed every time. Float time step. Good. Or no, it's not. Yeah, well, whatever. We're gonna do it with float time step 001. And we just go ahead and go time step plus no. Time plus equals time step, of course. Time step. Okay. So we had the time step. Now we need to turn the whole thing by a time step. How do we do that? Well, we just add it to this thing. Time. Should be working, right? Yeah, it's actually turning backwards, but we will allow it. We will allow it. No, we will not allow it. I don't like this. I do not like. How would I do this though? Because if I go just like subtract it, it would work for some time. Time equals time plus time step modulo pi. How about this? So we just go like 2 pi here. We subtract the time. And now it should work, right? Let me put this into parentheses. Not the most efficient way to do it, but whatever. We're running Java. It's all pretty fine. Okay, so this is really cool. Now let me make it bigger, because we were still working with like tiny sizes from our P5.js adventures. So now, yeah, that's it. Okay, so now our time step really small. Let's fix that. We just go up here, and that's still too small. It's flickering. Oh, what was that? Oh, right. We need this to oscillate. Damn. We need this to be modulo 2 times pi. How about this? Or we just add twice the times, which would be probably better. So we do this right here. We're still getting artifacts. Okay. 2 times pi. Maybe that was not the fix I wanted. I don't like that it's so jittery. We're still getting the artifacts. Okay. Which is when we get a smaller value. So let's go 4 times pi plus the thing. Will that fix our problem? And let me just go ahead and adjust the time step for a little bit more. Oh, no artifact here. Nothing here. Okay. Looking good, looking good. Right. Frame rate. Is it like this? Frame rate 60. Does this work? Or is it locking a thread? Yeah, I think that's the thread locked. Okay. So that's why it's laggy. It's not efficient. Okay. So now the thing I want to change is I either want to go ahead and make the time go faster and slower, or I want to have the dilation, the thing. So basically the amount of curvature you get. I want to adjust that also depending on time. And I want to make it so that it goes ahead and fluctuates depending on, well, basically it describes a sine wave. So let me just real quick get this up here. still really interested in who the guy that was watching before is. Be really interesting. Whatever. Okay. Now, what was I about to do? So yeah, adjust the thing, the curvature, like this offset multiplier, depending on the time. So for that, I will get a offset mult default to 0.15. This can just be 0. And then a offset mult, like basically a delta, how much up and down it goes. So I might want to adjust this to be like 0.02, because now, no, 25, and I want the delta to be 0.01, so it goes between 0.015 and 0.035. Okay, great. So now we adjust the multiplier depending on the time. Offset mult equals the delta, so we need a sine wave depending on the time. Sine of the time, which goes between 0 and 2 pi, which is perfect. Sine goes from 1 to 0 to -1. So we want to multiply that by the offset mult delta, and we add the default offset multiplier default. Okay, that should be it. Wow, that's trippy. Dang, that's really trippy. Okay. Woo! Ow. Beautiful piece of art. Beautiful, beautiful, beautiful. So now I want the I want to make it adjustable. I want to extract as many constants as possible so I can put it up on GitHub and make it accessible for everyone. So how are we gonna do this? We do stuff like this. Constants. No, Java does not have constants. We have final values. Final and I want to define these in the setup function. No, I cannot do that. Midpoint. So you can adjust the midpoint, obviously. I think there was a function where we could put in the size thing, setup. It was not set up. It was something different. So size loop draw. There's some other thing. So let's look at the reference. The reference. Where is setup? Okay, setup. Oh, we should link to threads. That would be real good to have this multi-threaded. All right. Okay. push style, public private pop style, pop. Exit, catch. I'm pretty sure there was a function where you could do the setup stuff without having to rely on variables. No, the other way around, where you could put in variables for size. Where is the size function? Size. Okay, setup. Use the full screen function. Okay, we could do that. Something larger, use create graphics. Okay, P2D, which are the different renderers? As of 3.0, to use variables as the parameters of size function, place the size function within the settings function instead of setup. In the settings reference page. Okay. Settings. Which is perfect, which is exactly what I want. We also can remove the call to background because we are always redrawing for every pixel. So that is, we can clear up that time for the GPU. Yeah, that's basically what I expected. Why is it telling me to go here? It's new with 3.0. It's not needed in most memory. We want to define the size. Okay. Yeah, let's go. Void settings. Let's go here and have a int width to be 800 and int height to be 800 for now. And let's put them in here. Make them final. And later we can add documentation. Okay. The midpoint function can go in here. Can't make it final though. Huh, how do I extract this to the outside? Oh yeah, of course I can. Holy stupid. Width and height. So now we can theoretically set the midpoint to this and height divided by 2. So now it should be a totally different point, right? Frame rate 60. Cannot put that into this apparently. And yeah, still working. It's just in a completely different spot. So let's change that again to have it back. Let's make it final. Whoa, well, maybe it doesn't need to be final. Maybe someone wants to move it. So let's for now. Yeah, well, let's make it final. You could move this midpoint during running, which would also be fun. Somehow I can see that working. I might try it out. But for now, let's go ahead and make this the final offset multiplier default. Default sounds weird, but let's keep it like that. I should be using let's go like this. We're defining final variables, so it's legitimate to use all caps. Offset multiplier default offset multiplier delta. This one is changing, this one is also changing, this one is not. Can I move this somehow? Nope. Final. I'm gonna add comments to those later, so don't worry. Okay, so now I changed these names. I need to put them back in. Midpoint. Default. And I want to make it work with the pixel density. Oh, what did I do? I mean, it's looking real cool. I'm not sure what caused it to be like this. It's going the right way and turning interesting back. I did something. What did I change? Shouldn't be happening. What am I missing again? Can I put in some big value in here? No. It's doing something with the delta. Oh, yeah, of course. Yeah, sure. If I copy the wrong text, it's gonna do the wrong thing. Even though it was really cool, not gonna lie. It was not what I wanted. Okay. Make this all caps, time step. Copy it, put it down here. Still working. Now, let me look at the pixel density function. I want to put that in. One or two. It makes render using all of the pixels on high resolution screens like Apple Retina displays and Windows High DPI displays. This function can only be run once within a program and it must be used right after the size and setup. Pixel density should only be used with hard-coded numbers. In almost all cases, this number will be 2, or in combination with pixel density as the third example above. Display density, I mean. Display density. Okay, so pixel density is something different here. Okay, so print line pixel width, pixel height, doesn't say what that should give me. So probably I should be going through pixel width, right? And pixel height. Pixel width, pixel width. Except it's the other way around. Pixel width. Why is pixel height marked as a keyword and pixel width is not? Tell me. Pixel height. Okay, okay. Sure. That should basically be everything, right? Because I have twice the amount of pixels. Am I using width down here? Yeah, we need pixel width. And yeah, that should be fine. That should make it work. Okay, so what do we have now? We have this thing working. Yeah, so now next problem. Now that we added the pixel density thing, it's only using one thread at a time. And as you can see, I have lots of processing cores which I could use and it's still lagging. So I want to look into threading. And we have here an API thing of thread. So I wish OBS had like a chat thing for YouTube, because it does have that for Twitch, but well, whatever. So thread request data. Follow a specific sequence of steps, first followed by draw over and over and over again in a loop. A thread is also a series of steps. Animation thread. All the thread sequences, however, can run independently of the main animation loop. In fact, you can launch any number of threads at one time. They will all run concurrently. You cannot draw to the screen from any function of a thread because it runs independently. The code will not be synchronized to the animation thread, causing strange or at least inconsistent results. Use thread to load files or do other tasks that take time. When the task is finished, set a variable that indicates the task is complete and check that from inside your draw method, blah, 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 blah. Okay, so what I want to do is calculate the stuff on a different thread and then on the animation thread, update the pixels array. Okay. Pixels array. So let's implement multi-threading. For that, I will use final int Threads, let's set it to like 8 for now. I know most of you probably don't have 8 threads to spare, but I do, so let's do that. Then I will have to split this up. First of all, let me look at the docs again. Red. Okay, can we add parameters to that? Because like this is really, really cheeky. Thread, execute a function in another thread, like wow. What do I want to do? Because I do need to synchronize these things. There needs to be some kind of synchronization. Otherwise, we're gonna get garbage. Okay. Cool. We need to split it up. That's fine. We need to draw it to the screen at one single point. Do you think it is legitimate to launch a new thread in a draw call? Yeah, apparently it is. Is it legit to do it every draw call? Maybe. I mean, let's try. What's the worst that could happen? Okay. And we need a what kind of array are you? I know I can put in a color. Yeah, whatever, let's just put in a color. Oh, so this is not just gonna work like this. Oh, like multi-threading is hard. I think I'm gonna just, spin lock it. Java atomic boolean. And yeah, perfect. We need a atomic boolean array. Thread status. This is gonna end bad, I can feel it. I can feel it. So basically what I want to do is, or what my idea was, so give every thread an atomic boolean that tells it to calculate its part. This should work most of the time, but it will not always work, I think. Because what if a thread does not run before whatever. Let's just lock that stuff. Processing lock. Hello. A lock. Do we have a lock? Wow, that's a nice example. You know what I was looking for? Caps lock. No, we don't have locks, so we need to import the actual Java library. Java lock. Concurrency tutorial. Yeah. Sure. I want to blah 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 blah. Oh, that's a synchronized thing. Yeah, I haven't done concurrency in Java for a long time. Okay, so tell you what, I'm gonna keep it like this for now. Let's try it again to see if it runs. Running perfectly. You could adjust the palette to fit your needs. Could clamp the colors to something. Use an actual palette with a mapper, and yeah, I want to make that a thing sometime. But I don't have much time left today, so let's go ahead and comment it. Put it onto Git and be happy. So, doc comments. Yeah, something like this. Width of the window, or how do you make Java doc comments? Documentation with Java doc, you do exactly this, except you just indented one thing. Okay, great. Width of the window, height of the window. Midpoint of the spiral. The default value of the offset multiplier. Currently unused, so I'm gonna throw it away, just like that. Okay. fixed time step. I should actually make these small. What am I doing? Fixed time step of the calculation for spinning and dilation. And this is the amount basically the thing that changes the default. The delta, the maximum delta value that is applied to the default. So that is done. Let's remove this space here. I think it would be fun to make a website that allows me to like use handles and stuff to change these parameters. I think that would be cool. That's a thing for another time. Maybe. So we could extract this function to maybe get the cosine of something, the tangent of some of the delta. Well, the cosine wouldn't actually make a difference, but you could take the sine of twice the time to make it twice as fast. You could add 2 sines of the time. And yeah, let me do that. Void. No. Okay. Actual code. These are 8, these should be 8 too, okay. Function that is applied to the delta. Function that determines the amount of delta that is applied. So we get a float back. How do I call it? Offset function. Offset function. And it takes a float time. For now, this can be return sine of time. Here we do offset function of time. So now we have what we expect. Now what if we do just return 1 or -1? Let's just return -1. So now we should get a constant spinning, which is true. So now what if we go ahead and do, let me real quick open GeoGebra and give me a nice sine wave. Sine of x, and we want sine of 2x. No, we want 2 times sine of x plus sine of x. Plus sine of 2x. Yeah, that's a nice function. Okay. And I want this to be a little more spread out, so I want to do sine of x divided by 2. Oh, this didn't spread it out more, so I want it to have this 4x, and this to be like 2x. Nope, that doesn't spread it out. X divided by 2 and x divided by 4. That spreads it out. Okay, so now let me get this back. 2 sine of x, make it 4. Nope, that won't work. I need it to be between 1 and -1. So I need to divide that whole thing by 2. Okay, now it should be about right. Okay, so sine of, do I need this divided by 2 here, really? No. This is giving me a way better thing. Okay, so sine of x plus sine of x divided by 4 divided by 2. Okay, let's try it out. What was that? Okay, first of all, parentheses divided by 2. And then we put in sine of x. And then we add sine of x divided by 4. And x is our time. And we need another pair of parentheses. So now it should look like a little bit weirder. Okay, that doesn't work really that well. Okay. Oh yeah, because suddenly we don't have a phase. Don't have a phase of 2 pi. Dang. Okay. Sure. How about we subtract this difference, so we turn it the other way. Now we add the time. We don't need to modulate the time anymore. Is that true? Let's find out. Yeah, it's spinning to the left, and I'm pretty sure I saw some let me see, slower, faster, a lot, slower, faster, slower, yeah, something like that. So in the beginning we are getting a little artifact. Let's just add just more pies. Yeah, no more artifacts. Great. Great. It's working. Okay, so now we have a offset function that's working. Let me just put in the normal sign function again, which looked a little bit prettier. Okay. Now, I think that's everything I want to make parameterable, or I want to parameterize. I'm not sure. Whatever. So let's get to getting this thing. Am I logged into GitHub? I don't think so. Can I sign in with my Google account? No, I cannot. So, tell you what, I'm going to put this onto GitHub later. I'm gonna put it into the description of this live stream, and you can get the code there. So, otherwise, I think that's it for today. It was nice, I think. Stuff is working. Let's look at it again. Yeah, it's a little bit too bright for me. Wait, let me fix that real quick. Can we do saturation like 50? And brightness by 50, and now we should have something a little bit dull. Saturation 80 maybe. And that's dark. Yeah, that's better. So now it's not burning off your eyes. How does it look on stream? Yeah, that's better. Way better. Okay, great. Thanks to everyone who's been here. I really appreciate it. Helps me grow bigger, which is like my goal. To reach more people with the stuff I do. And I think that's great. So you're gonna get the code in the description, maybe an hour from now, once I get to it, because I'm gonna have dinner first. And yeah, I'll see you then. I hope you have a great evening, and goodbye.